Live from New York, it's Asking Engineers.
Hey everybody, welcome to another fantastic and fun Asking Engineers. We're broadcasting live from the old Adafruit headquarters. With me is special guest John Engineer.
Hello.
The engineer.
Director of Imaging.
Director of Imaging. And Analog Master.
Oh, I don't know about that. Thanks.
More so than me. To my right is Phil.
Hello.
Phil's still here. He's on camera control.
Yes.
We're all wearing black shirts.
Yes.
Company
dress code.
We're in a band.
Okay. On tonight's show, the code is December, 10% off anything in stock in the Adafruit store up until midnight tonight. December. We'll tell you what that means because it's a weird name. We'll talk about all the great folks that were on the show and tell some amazing projects this week. Introducing John Engineer, Director of Imaging at Adafruit Industries. Colin joined the team. A special hello from the team at Adafruit. Circuit Playground has an update. We got Mickey Monday. We got some birthday celebrations. We got a month of STEM, or STEAM, depending on if you'd like to include art in that. December. Got a project from Bill in support. We've got a contest we're doing with TI. We have a news segment, Time Travel Tuesdays, where the 21 gigawatts murder. Great Scott. Where we look back in time. We've got mailbag. We've got some news from the community. We've got gift guides galore. We've got some news from the world of open source hardware. We got some cool stuff from the Adafruit learning system. We've got some news in the Arduino world. We've got tutorials for Raspberry Pi. We've got Wearable Wednesdays. We've got 3D Thursdays. We've got Pi Day. We're going to have a special sneak peek at the Raspberry Pi Model A. John Engineer is going to talk about taking amazing photos of your electronics. So get your photography questions ready when we get there. We've got new products. We'll answer your questions. We have a trivia question, and you know what? We still got the cat. All that and more.
Cat's also wearing a black t-shirt.
Ask an Engineer. Okay. This is a show.
Okay.
This is a show. Okay. Let's get let's pay some bills real quick.
Okay.
Everyone, the code is December. 10% off. Everything in stock in the Adafruit store. We decided to we used to just do kits that we make, but now we're just doing 10% off. It's easier because we have lots of things come in.
Stuff come in.
Yeah, and so 10% off everything. Ends at midnight though. Show and tell. John, this is the first time you've been on the show and tell from the other side of the camera.
Yeah, it is.
Yeah.
What's
amazing
it like?
night.
It's the set's smaller than you think, right?
Yeah, it's much smaller. But
this
really
was a historic show and tell that we do over Google Hangouts. This was the first time that I know of that it was broadcast through a robot that Dino made, and it's the Mojo platform.
Yeah, that was intense.
Yeah, so the Mojo platform,
cool.
There are these little modules that you plug in and have sensors, and as soon as they're on, they announce themselves to each other, and then you get all this functionality.
This was an intense robot. It had like XP and a motor driver and a power system. You should go check. It's probably on
wireless
YouTube.
Video.
It'll be on YouTube in like 10 minutes. You go check it out.
Yeah. Darius had the Blinky board. He did a really cool proposal for a grant for a school, and he got it.
Yeah.
And it was to teach electronics. The board has instructions, and look for a link in the show notes on the Google Plus page. Jay had a GPS clock and a solar bot. That was really neat. When it wakes up, it points at the sun. His GPS clock is basically a solderless GPS clock. You just plug things into a breadboard.
He plugged in. Well, there's a little bit of soldering, but there's no custom circuit board.
Yeah.
It's just an ultimate GPS, which gets really good range. I saw it was getting a fix inside his garage, which is pretty cool.
Oh, it might be modules, not Mojo. I get that Doors line. Got your Mojo Rise. That's all I could think of. Yeah,
Mr. Mojo Rise.
Anyway, and he had a 7-segment LED backpack and a micro, and so it's all fit on one breadboard, which is kind of fun.
Yeah, and then Ken had a Raspberry Pi Wiimote project.
Yeah, over Bluetooth.
Yeah, and then Kristen had a really cool LED project that used our RGB LEDs.
Yeah,
really cool Arduino
bright.
project. It was super bright. And then Cecil had this wire.
He had a wire antenna. I think he was tuning the wire antenna using a standing wave reflection meter to determine how long to cut this wire.
And he was walking and cutting and demonstrating.
And there was a lot of charades. I don't completely understand. Maybe he'll come back next week and talk us through it, but it looked cool. And then he had a really nice text code.
Yeah.
And a Metcal.
With modules.
Participant. So on the show and tell, we'll get a show and tell sticker. Make sure you email us if you're on the show and tell, and we will send you out as seen on the show and tell sticker.
You can stick on your project, or you don't have to.
Yeah. Someone on the show and tell had one of the show and tell stickers.
Yeah.
Lady Ada, how does someone get on the show and tell?
It's super easy. Go to our Google Plus page at plus.google.com/plus Adafruit.
Yeah, google.com/plus Adafruit.
No, but it's plus.google.com.
No, you can just do google.com
Really?
/ the plus symbol Adafruit.
All right. It's even easier. Google.com/plus Adafruit. That's our Google Plus page for Adafruit. And look for the post where I say, comment here to get added to the circle. We'll add it to the circle. And then any week in the future when you have a project to show off, you'll be added. And you can show off your project. So it's cool. You just do it once. And you can join the fun and the party. We have a party, just like 6 of us.
The show and tell is fantastic. It's now... I mean, doing Ask an Engineer is fun, but the show and tell, we get to interact with all the community and customers.
Yeah, and people post in the forums, but then we get to actually see, what they made. It's not a good place for tech support, but it's a good place to show off what you've made.
No, it's just show and tell. We don't do tech support over video chats yet. But one of the other things is, so that's how we met Tyler and Justin, and we hired them, and they worked at Adafruit. So for us, this has been fantastic. We meet makers, and also, John's been on the show and tell, and now John's Director of Imaging. And speaking of, that's our big news.
Hey.
John joined the team.
Just his head.
Just me.
Yeah. John joined the team. John's Director of Imaging. John, what are you going to be doing at Adafruit now?
I'm going to be photographing all the new products and coordinating on videos and stuff like that, so we have a nice matching sort of image that we present to the world. And I'm going to be working on lots of cool projects, taking shots around the shop, sharing what's going on at the Adafruit factory, stuff like that.
Yeah. And
Coffee.
One of the things that I like about John is he actually has the ability to make electronics as art. His photos, they look so good, they look unreal, and they're also kind of gothic and kind of dark like us. And and he has a really good design aesthetic. So he's able to take kind of what I think Adafruit is, and each product, and we'll get to those in a bit.
Starting this week, we have 3 of our new products have John Junior photos, and you can really tell, because my photos are like, here it is on a white background, and then I use the eyedropper tool.
So there's also other big news. Colin.
Look, it looks here like we got 2 Collins.
Yeah, we got 2 Collins for price of 1.
We actually only got 1 Colin.
So Colin has joined Adafruit Industries. Colin is a creative engineer. He has been doing Circuit Playground. And a lot of people know him from at Make. I had hired Colin at Make a long time ago when I was kind of doing more with Make. Now I just write articles once in a while. And Colin did this great series called Make Presents. And it had capacitor and transistor, and it is amazing. It's kind of like the Connections or the wildlife shows, the Attenborough guy, where he talks about the way the world works and everything. So Colin has he's an excellent educator, an excellent teacher, a fantastic iOS developer, and he also filmed the.
And he wears a great suit.
Yeah, and he also filmed the Circuit Playground overview, and also all the Make Presents videos. So multi-talented person, just like John. We're really excited to have John and now Colin.
And he's in Brooklyn. So it's cool. We're like hiring local.
That's right, local talent.
Local engineers. People say you have to go to Silicon Valley to get good talent, but that's totally not true.
Jersey and Brooklyn now.
That's right.
Speaking of the Adafruit family, we had a little company get together, and everyone at the Adafruit factory would like to say hello. Ask an Engineer Eyes. This is the first time we actually had someone who could take a photo, and John set this up, and this is all the people that are actually at the Adafruit factory. So moving right along. Anyways, that's us. Circuit Playground had an update. Speaking of Colin, a couple quick things that we added. Let me go to the screen here. This is just for the folks who have it. LED resistor calculator now provides power rating. That's really important. Bug fix for Ohm's law calculator and a bug fix for LED resistor calculator. The build is solid. We're really happy with Circuit Playground. Check it out if you have iOS devices, and it's out. It's great. You get
and if you have Android, check out
Electroid.
Electroid
we like a lot.
Which is an excellent alternative for Android users.
Okay. Next up, Makey Monday. Every Monday we have Makey projects. This week, I just wanted to highlight one quick one. This is a Barbie project that these girls set the Makey up. So Barbie is a keyboard.
That's cool.
Really neat. It's speaking of, by the way, this little animated GIF, and this is in John's world. We started adding one of our announcements this week. We started adding animated GIFs to Adafruit. So for all of our products that light up or blink or move or do something, we have an animation. So, John, you're working on those, right?
Yep. Yeah.
Yeah. What type of animations do you think we'll start to see? Which ones have you been working on?
The ones I really like are the ones that are really subtle, where almost everything is in a stasis
You have to
and then
stare
something
at it.
changes.
Yeah.
Like the cufflinks are like that, where it's really slow and then it's...
Yeah, so if you guys look at the adafruit.com/icufflinks, they pulse out, but you have to kind of stare at them for a few minutes. It's really neat. Celebrating a birthday this week, Lady Ada Lovelace. This was on the French site, and then it was on the U.S. site. Ada Lovelace, a countess, considered the world's first programmer. Very cool. Mm-hmm. She was hanging out with Babbage, thinking about future.
Writing code.
Back in the 1800s.
Writing code for a machine that didn't work, and then they ran it like years later, and they found out it worked perfectly the first time.
Yeah.
It's pretty amazing.
Very cool. And in our store we have these Ada Lovelace stickers and all sorts of stuff. Lady Ada, you were on a special Google event. It was this is where the code comes from. Distember.
Yeah. Distember. Google and Girl Start working together, and they did a really cool 31 days of Google Hangouts and
still going
events
on?
and showing off. Yeah, right. It's still December.
Yeah.
So we were at the halfway mark. So definitely tune in.
Yeah.
I did. Yesterday, Friday. What day is it?
Yeah, you did the Friday. You did the Friday on the field visit.
Field visit, but they also have tons of other awesome people showing off stuff and stuff in the future. So please go check it out. It's in the afternoon, and I think they record it as well on YouTube, so you can always go back and watch the old ones. But if you watch it live, you can ask questions live through the chat, which is super cool. So people were asking me questions live about the pick and place and like how do I engineer projects and how do we design stuff and the process by which things get made in the factory. So that was really cool.
There's links to it in the on the blog. Bill, who is kind of running a lot of the Adafruit support in the forums, did a really cool project with his son. This is a light up thunderbolt or lightning bolt. But one of the things that I wanted to mention,
that's the first team, right?
That's the first team. Yeah, they made this augmented doorknob for the elderly with disabilities, and it was from the first Lego League. And he's a parent, a coach, and for their fourth year of doing it, they built a RFID actuated door for disabled senior citizens using a bunch of Adafruit parts.
Because it's actually hard sometimes to put a key in and twist it. Even I have difficulties. You have to twist really hard, and
it's an awkward movement.
It's an awkward movement, and I know definitely people in my family who, as they get older, they can't open doorknobs or twist keys very well. It's a very difficult motion. So having RFID, something with a bracelet or a key, that way you don't have to. You just swipe your hand over it and it unlocks.
Yeah.
And then you just push the door open.
Next up, we had we were doing a contest with TI, and it's on adafruit.com/beaglebone, and anyone can win. And you can also enter your own cape design. Mm-hmm. Here's the trivia question that we did. Lady Ada did a video. Here it is.
Hey everybody, it's me, Lady Ada, here at the Adafruit factory, and I'm going to show off some really cool BeagleBone stuff. This is the BeagleBone cape that Kevin Townsend, one of our engineers, designed. When we saw the BeagleBone for the first time, we thought this would be such an awesome DIY platform for people to build cool projects. But one of the things that would really help out is having a prototyping plate, something that goes on top of the BeagleBone, make it easy to put components on it, to break out all the pins, maybe even give you some surface mount spaces so you can prototype a surface mount. So this is our awesome plate, and we designed it that it would go inside of a box too. So this is the cape inside of a box, and you can see there's plenty of space if you wanted to solder some components on top. And we even have these awesome stacky headers, so you can stack another cape on top of it, which is awesome if you want to expand your project. And as a bonus, here's a special trivia question. On the bottom of a BeagleBone, there's this connector here. It's not populated. What is this connector for, and what part number is it suggested that you use if you want to solder it in? If you think you know the answer, check out the text that goes with this video for more information on how to submit your answer.
Okay, and if you want to enter that contest,
you can still enter.
Yeah, it's adafruit.com/beaglebone. Okay, next up, we're going to go really fast because I want to make sure we get to everything tonight. We have a new segment on the site called Time Travel Tuesdays. And
when we turn back the clock.
Yeah, what's happened is there's so much that's happened in the maker movement for so long, and because there's blogs and we've been able to keep track of everything, we thought it'd be good to start looking back at all since we've kept track of it. So I started Hackaday, so I have all my old posts from Hackaday. Then I have tens of thousands of posts from Make, and then the old Adafruit blog, the new Adafruit blog, Lamore's Flickr account, my Flickr account, Make stuff. And so here's just a quick look back. You have to check out the post because there's so much information about what was going on last year. So in 2011, around this, on that day, last week and Tuesday, we were in full production mode of the eye necklaces. That was awesome. 2010, we were about to get sued by Microsoft for doing the Kinect hack, and it was pretty scary and pretty intense. But then eventually, Microsoft turned that into a big business division, and they loved the hacks, and they said how great it is that hackers were doing cool stuff. Yep. So we didn't get sued by Microsoft. 2009, I had released an open source hardware guide. This was when you could still kind of sort of keep track of how much open source hardware, but not really. I had to do big categories, and it took me a full month to like do this article. I can't keep track of it anymore.
I remember that article.
It was massive. Also in 2009, this is when we were shipping and doing all of the kitting, Lamore and I, at night with a very small team. And Ask an Engineer was on an extra laptop that I had, and we would just film shipping, and it was kind of when we were just getting started. We also had a special guest, Nate, the CEO of SparkFun, was on Ask an Engineer back in 2009. In 2008, we had started our laser etching business, and you were working on the wave bubble. What was that? What's the wave bubble for the folks at?
That was my thesis project, and also a project at IBeam. It's a DIY cell phone jammer. The project is still people still make it. It's the documentation's on the website. So that's all good, but this was when I was designing the current iteration. Yeah,
so check out all the links, and you get a really interesting look back. Then we have sections from Make and Hackaday, and then what happened this day in science. All sorts of cool stuff. It's really neat. As we've added new people at Adafruit, I wanted to have this post with all these links, so people that just join, they're going to get this assigned, so they have to go back in time and look at all this stuff. What's cool is to see the really old old photos on Hackaday. What I did is I made them black and white, and I made them look like they were pieces of tape, and the whole site was in lowercase. Some people didn't like that.
Yeah, you did that with CSS. That was really funny.
So, all right. Next up, mailbag. Every week we have mailbag. Mailbag this week. Person Laura emailed in. Hi, thanks for all of your help. I got my package a couple Wednesdays ago. I've been crazy busy, and it made me so happy. Thanks for all your help and reassurance that all the logistics would work out in the end.
Yay, logistics.
Awesome.
Yeah, so we do those every week. Mailbag creature.
The mailbag entity.
Google Plus Communities is now 2 weeks old. It is rocking. We're going to have 20,000 people probably tonight already. And our community, we didn't want to just like have Adafruit. We did makers, hackers, artists, and engineers. And we thought that was a great kind of big umbrella that everyone can have something in there. We have photographers, we have people who paint, we have people who do engineering, we have scientists. And right now, last week I showed a little bit about the community, but this week I wanted to show, here's some of the other communities that we join that are a lot of fun. So, of course we're in ours, but there's also Make has one, Robot Party Rockstars, Hacker Spaces, Open Source Initiative, Open Source Software. I don't know which one's the real one, so I went to both. Maker Spaces, Raspberry Pi. There's like 20 Raspberry Pis. There's also like 20 Arduino ones. I don't know which one's the official one. 3D Printing, Linux, and STEM on Google+. So those are the ones that I like, and we're in there and we're doing stuff. Do join the Adafruit one. We're going to do a lot of neat stuff and put like stuff that you'll only find there. Moving right along, gift guides. We have Enclosure gift guide, iOS device gift guide, gifts under $20 gift guide, and then we have the clock gift guide. Check those out.
I really like that one, the clock one.
Yeah, I don't even know what the hell that is. It's like some weird like Nixie spinner.
Next up,
thing.
News and open source hardware. Just a quick announcement that happened that was really neat. Arduino announced the Explora. It's this. It's like a all-in-one board that has all these different things to
it's a Leonardo board. It's an Arduino Leonardo
slider,
but it's got like all these things built in, so it's kind of a neat controller. It's got an arcade joystick thingy with a select button. It's got 4 up, down, left, right buttons on the right. It's got a slider. It's got a microphone. It's got an RGB LED. It has an accelerometer. It has a I said the microphone already, right? I think it has a piezo beeper.
That's cool.
It's got It's got a light sensor, right?
Yeah.
I'm like trying to think of all the sensors. It's got these Tinkerkit connectors,
Yeah.
and then it's got some plugs so you can. They'll have an LCD, and it's probably going to be something like our 1.8-inch TFT LCD because like the pins look. Their names significantly similarly.
We're gonna stock this, and I guess to give people a background. So we've been working on something like this for a while. The Makey came out a long time ago. When we saw when Jay announced it at Maker Faire last year, and we're like, oh, okay, with this kind of taken care of. Now we see the Explorer. So we also have something coming out soon as well. So we think we have some fun surprises. But we'll have this in stock as soon as Arduino is shipping.
Yeah, we ordered a bunch. They said in January. Right now, I think there's an exclusive with Radio Shack only.
Yeah.
But as soon as we can get them in stock, they'll send us some.
Yeah. Cool. Okay. Next up, new stuff from the Adafruit learning system. Learning system is rocking out. It is.
Yeah, these are updated tutorials.
Yeah, so we're going to go through these really fast.
So we put the Chumby Hackerboard tutorial in. We've also put in the 16x32 and 32x32 RGB panels. These are awesome and bright. That tutorial's updated. We also put in the Bento Box tutorial. That tutorial's updated.
Yeah, we have
also
tons
have
of Arduinos tutorials.
one a day. We have put in one. We've made live one Arduino tutorial a day.
We have 11 right now.
We're up to 12.
Wow.
Yeah.
First up, piezo. And then, sorry, that was a piezo theremin type project, a light sensor. This is LCD part 1. And then there's also LCD part 2, where you use the LCD tutorial from part 1 and you display like the temperature. There's also using a potentiometer and a light bar to show the analog inputs and outputs. And then I think this one was the same but with a light
Part 2.
sensor.
Yeah.
I'm trying to remember. From the photo, it's hard to tell. But yeah, so it's basically sensing and LCDs. So
and then 2 Raspberry Pi ones with Lady Ada inside.
We have Raspberry Pi tutorials. We had one on how to install your operating system onto an SD card. This is kind of the hardest part for most beginners, how to get that distribution onto an SD card using SD card writing software. And then we also had one on how to set up your... Actually, that was from last week. And then this week was how to set up your Raspberry Pi once you booted it, so how to configure the time zone and the password and whether you want to boot into the desktop or stay in text mode. So yeah, that's kind of cool.
Okay.
And then finally we had a tutorial on how to set up networking. Maybe that was this week. I don't remember. There's so many tutorials. This one was how to set up Ethernet or Wi-Fi, so you can set up both using either Raspbian or Aux Analyst, which is very similar. And so it shows you how to do it using either the GUI system or using text. I usually just log in as text. So it shows you how to do both and how to find out what your IP address is so that you can connect to your Raspberry Pi from the outside world and do stuff with it, display sensor data or whatever.
All right, and then next up is Wearable Wednesdays. This is when we spotlight some Flora projects, but we also put other things in. So this week we have a video from Becky, and this is for Times Square, our new DIY watch that you can make.
Detailed instructions for the Times Square Watch Kit are available on the Adafruit Learning System, where you'll find all of the tools necessary to complete this project, as well as a step-by-step guide for where to place each component. When it comes time to install the LED matrix, it's important to get it in the right way the first time, because it's hard to desolder it if you put it in wrong. See where it says matrix text on this side and has a little arrow? That side of the board should line up with the text on the side of the matrix. Carefully solder the matrix in place, and then install the watch's battery. You can then set the date and time on your watch by holding down both buttons until this menu comes up. The year is first, and you press the right button to change the number and the left button to move to the next number. So the date is stored in the format of year, month, day, hour, minute, and then also gives you an option of displaying the time in 12-hour mode or 24-hour mode. Hold down both buttons again to exit the time set menu. To assemble the watch, insert the acrylic plate inside the band. This will insulate the circuit board from your wrist. Next, you can install the watch assembly inside the band. The small nubs on the circuit board should nestle into the grooves in the watch band, and it can help to tug on each end of it just to get everything settled properly. To switch between watch modes, tap and then hold one of the side buttons. The second mode is the battery indicator, which lets you know how much battery life you have left. The third mode shows you the current phase of the moon. And the fourth mode is a binary watch. The Times Square Watch Kit is Arduino compatible and open source, so you can design your own watch modes and upload them to your Times Square. And if you do, be sure to share them with us in our weekly show and tell on Google+. And don't forget to give us a like, a share, and subscribe to our channel here on...
Great. I guess John, yeah, the cat showed up here.
Yeah.
MOSFET wants to be on the show early. John,
You can't see him because his black t-shirt.
what's the challenge when you're filming LEDs on a watch like that? We're going to talk about some photography stuff soon, but what's the big challenge with something like that?
The challenge is LEDs are really strange with the color they output. It's very narrow. I mean, it's basically a single wavelength, and they tend to sort of, at certain angles, saturate the sensor so much that they get blown out. Where there's no detail at all. It's just
This is a blob.
It's red, but it spills over into the green, so it looks like it's got this like weird magma orange center.
Yeah,
And then there's like a red halo around it.
Yeah.
So what happens is you have to underexpose for the ambient light in order for the LED to show up correctly, because the LED isn't just producing its own light. There's also light from the room that's getting into the LED lens and bouncing around. So it's adding to the illumination. It's very hard to get them balanced properly, especially against white.
Yeah.
A white background, because by definition white is the brightest thing in the scene.
Yeah.
So it looks weird if the LED is not lit super bright.
Yeah.
Or if it is lit super bright and it's too bright for the
Does
white
it also
background.
flicker? LEDs flicker too,
It
right?
can if your shutter speed is too short. When you're filming a video, you actually get this thing where they sort of have a beating
Yeah.
between one and the other. It's like a
flicker
heterodyne
and
effect.
And people are like, oh, like your LEDs are flickering. It's like, no, it's just the display.
So how do you get rid of that when you
Well, to get rid of the flicker, you'd use the lowest possible. You may have to play around with the setting too. You may have to set it to 24 frames per second or 25 frames per second if you have that option on your camera. Use the longest possible shutter speed, so you're basically integrating over those pulses rather than...
So it's exposed for it.
Yeah, you're trying to sort of average it out rather than maybe catching the tail end of one and the beginning of another.
Yeah. Can you put anything over the LEDs? Any type of filter? Or?
You can put like neutral density filters over it. That'll help a little bit maybe.
Yeah.
Honestly though, the easiest thing to do is, if you have full control over the room light and the light on the LEDs, is really just play around until you get them matched.
Gotcha. And that's what you do. You'll actually
Yeah, in the studio I have full control over the room light, so I can
Yeah.
flood it with light. But again, you have to be careful. You don't want to hit the LEDs themselves with too much light, because then they'll just reflect right back at you.
And red is the hardest.
Red is the hardest.
The other colors are not as bad. Red is definitely the toughest because it bleeds into the IR, I think.
Yeah, blue looks blue.
Blue looks
it
blue.
Doesn't really. Sometimes it gets a little teal in the center, but it's not so bad.
Okay. Well, we're going to keep moving along. We'll talk about more photos soon. Next up, we have 3D Thursday every single week, where we talk about 3D with electronics. And speaking of, Matt Griffin, Director of Community and Support at Adafruit Industries, is doing a class tomorrow, already sold out. And Matt is going to, we're doing this thing, since everybody can't come to our apartment at 11 o'clock at night, I don't know why not. John happened to be in the neighborhood, but we're having the staff make these short little videos about what they're up to. So here is Matt, and you can check out what he is up to this week.
Hey folks, it's Matt Griffin, Director of Community at Adafruit, and I've been spending a lot of the last couple of weeks working on the Times Square project. Love the new watch kit, and I am looking to make a 3D printed enclosure. Been playing around with lots of different solutions and have moved into Rhino so that I can create a model, not only share the case that I'm designing, but also share all the design files I used and all the techniques, including these cute little dummies that sort of match this dimensionally, so you can make your own watch designs. So I'm looking forward to sharing this with everybody and getting everybody out there making awesome stuff with the Times Square. Hey folks.
Okay, so in case you guys were wondering, are we going to have 3D printed enclosures that you can download and print on your own for the Times Square watch? The answer is yes. So we'll have a lot of other things to announce for 3D printing soon too. Big news. Can't talk about it right now though. Next up, Pi Day. Every Friday, we overwhelm the site with Pi posts. And everybody loves them. So this week on Pi Day, we have a few things. First off, Raspberry Pi redesigned their site, and they did something extremely nice. They have a special section that says Friends of Pi, and check out who made the list here. I don't know if you can see that, folks at home, but if you can't, I'm going to zoom in. Adafruit. Very nice of them.
Yay.
Yeah, and they sent us the first, I think in the U.S., there's only 6 of these.
It says
right
on the back like 2 of 6.
Yeah.
It's like, wow, there's really only 6 of these.
So we have the Raspberry Pi Model A. This is the $25 one. A couple things that Lady A is going to tell you that's different, but we have nice photos. We have a video on the site. And we're making sure everything that we're doing works with the Pi. $25, unbelievable. Lady Ada, what's different in this one?
Oh, you want to say live or?
Well, just real quick, and then I'll show the
Okay,
video.
sure.
What's the 2-sentence difference?
The big difference is that this only has one USB port, and it does not have the Ethernet circuitry or the Ethernet jack. So that means it uses a lot less power. It also means it's a lot thinner. It's not as tall, so it can slip into like a smaller space.
Yeah.
But mostly it's just lower power and lower cost because you don't need the Ethernet chip or the Ethernet jack, both of which are fairly
Only if we had a
expensive.
video that showed you doing like the power consumption test on. Oh wait, we do. Let's watch it.
What do you got there?
Hey there, I'm checking out these 2 Raspberry Pis. I've got the classic Model B Raspberry Pi. This is what everybody has out there right now. And this is a preview of the new Model A. And the Model A is meant to be lower cost and lower power. It's missing the Ethernet jack here and the Ethernet chip. It's also only got 256 megabytes of RAM instead of 512. Otherwise, it's pretty much the same board. So I'm checking it out with Oxygenolus. Basically, one of the things about it is it's lower cost because there's none of the Ethernet stuff on it, and it's lower power. So, for example, I've got both of them powered off of this DC power supply, and you can see the Model B is using about 310 milliamps, and the Model A uses only a third of that much power, only 100 milliamps. The extra 200 milliamps is what would be used to drive the Ethernet chip. Even if you don't have Ethernet plugged in, it still draws 200 milliamps. This is a way better option for a low power project or a project where you want it to be slimmer because it doesn't have as much height because there's no Ethernet jack on there.
Okay, that's a preview.
So check it out. Report back soon.
What do you got there?
Okay. All right.
So yeah, that was me showing off. I hooked it up to my DC power supply, which you can kind of see back there. Put 5 volts on both of them, booted them up, and compared the current draw from Model A, which was only about 100 milliamps, to a Model B, and that's even without the Ethernet plugged in. So even if you don't have the Ethernet plugged in, the power, the chip, I mean, we have Ethernet, we use even more power, but if you have the Ethernet chip, just draws 200 milliamps even when there's no connection going on. So there is quite a bit of current draw for that extra chip. So yeah, this is much lower power.
Does it matter if there's an Ethernet cable plugged in to the port?
That's what you said.
Yeah.
It doesn't.
Just
Okay.
quiescent currents, like 200.
Sorry.
Just the current draw is the chip itself.
Gotcha.
And the magnetics, yeah.
And it knows when there's something.
Yeah, but I mean, like the LEDs are missing on the Model A because you can't plug in Ethernet jack.
Okay.
The Ethernet cable to the jack.
Okay. Great. All right, John. We're gonna talk about some photos now,
Okay.
and we're gonna open it up for questions. And then we're gonna do new products because we have about 25 minutes left. So I have the photos here, and maybe you can talk a little bit about your process for shooting photos. So as you talk, I'll go through some of the photos in your portfolio. But what is it? How do you start out when you want to take photos of electronics or maybe anything? No pressure.
Wait, yeah.
Yeah, everyone wants to know gear, of course. Like, what do you like to use to shoot with?
Well, I like to have a pretty decent camera. Right now I have a DSLR.
Okay, tell me about this one. This one is kind of interesting because you said it was called focus stacking.
Yeah,
What
I
do you
use
do
a
for that?
technique called focus stacking where I used a Canon G series in this program. I don't remember the name of the program. I think it was like Z Stacker or something. basically you take pictures focused, macro pictures focused. Maybe you start at 10 millimeters and then you focus to 11 millimeters, 12 millimeters.
And you do this by hand or it's automatic? Use it.
There's ways to automate it, especially with the G series, where you can just the Chittick system. You can basically set it and tell it to do. It'll bracket it where it'll just do this in order.
Okay.
You can also do it manually with an SLR. Just kind of, if you put a ruler scale on there, you can kind of tell where you're focused at.
Yeah.
And then the newer lenses and cameras will actually record the focus distance, and then Z-Stacker will take that into account for scaling and stuff like that, and then combine all the images so that you get a really large depth of field image of something that's very small. If you were to just shoot one picture of that,
you usually either get the top of the chip or one corner of a coin.
Yeah, if you got like the frontmost pin in focus, the probably by the second nickel it'd be completely out of focus.
Yeah, and for something like this, what's different with the lighting? I mean, does it have to be like? Of course, the lighting always has to be great, but
well, I mean, if you really want to show off detail, strong collimated lighting at something of a low level where it's not like right above you. It's like in the wintertime when the sun is really low, and let's say it hits the side of a mountain and it really picks up the texture of the mountain. Yeah. Because it's at a low level rather than bearing down straight.
Yeah, because you want the shadows, because the shadows shows detail, especially in the nickels because they're engraved. Also, chips, they're engraved. They're also laser engraved, not inked these days. So you have to have not light from above, but light from the side.
Yeah, light from above will just completely wash out any engraving on top of the chip.
And then what about this photo? Like, it has a really interesting focus.
Very shallow.
Yeah.
Sort of
this
depth
is
of
very,
field.
very shallow. I think this was a 50 millimeter with at f2.
Yeah.
This was a really weird event that happened right after Hurricane Sandy, actually, where overnight all of these spider eggs hatched and they put webs up because it got really warm about a week later.
Okay.
And then the next day it was cold and foggy, and this happened and all the spiders were gone. But there was like webs everywhere.
Charlotte's Web. All right.
It's really wild. Yeah.
Sandy's Web.
Okay, and this is Nixie time.
Yeah, that was at Maker Faire, Rhode Island. This guy John Sarek is from Columbia University. He made this Nixie Sudoku game, and I went over there and took a picture of it.
That's beautiful.
And the light this was just environmental light. I didn't do anything with the light.
You took that around sunset, right? It was wasn't it like, or was it during the day?
I think it was towards the evening. I don't remember exactly when, but yeah, it was probably, I don't know, September, maybe 7 o'clock.
And then this one.
This was Maker Faire, Rhode Island, 2009. Mitch was running a workshop, soldering workshop outdoors. They had these generators up, and I really liked it. What first attracted me to this was the shadow of the bicycle on the paving stones. And then I'm like, well, I'm going to get the whole thing. So I did like a 30-second exposure.
Yeah, it's cool because it's activity. There's activity.
Yeah, it's like a hive of activity. This was the demolition derby at the New Jersey State Fair. I just really like the way this picture came out because, the kids are silhouetted against this crazy scene in front of them.
They're like the end of the world.
It's funny because the front of the car is like on fire, and the back of the car he's like throwing up dirt trying to get out of where he is.
Yeah, and the kids and when you. It's human nature when you see people looking at something, then you look where they're looking.
Right, it's like the ultimate spectacle, yeah.
Yeah.
That was the thing I did for the big build a couple of years ago.
Yeah.
Where I just grabbed an old modem board, and I grabbed my favorite light, which is a 1,000-watt Fresnel spot, and I set it up so that it kind of looked like the sun, and I photographed that. I had a reflector filling in some of the shadows, but that really beautiful strong light that you see, you can only really get from a Fresnel spot or something like that.
But how do you? But you have to be careful because you get really harsh shadows otherwise.
Yeah, so you need like a mirror or a white card to bounce some of the light back into the shadows.
I see.
Because if you were in nature, really, what we have is always one light source and a reflector: the sun and the sky.
Yeah.
So
I thought this was just an aerial shot in swanky town of Tron or something like that. That's very nice.
It could be that too.
Yeah. All right, and then this is another shot that you did.
Yeah, I was walking through a parking lot and I saw this leaf on the sunroof of a car, and I thought it looked really cool.
And then this is like a straight up shot.
That's from Cape Canaveral. Yeah, that's from the blockhouse where Alan Shepard went into space.
Okay. Now, the thing that everyone always wants to know is, tell me about the lighting that you just got for Adafruit and the camera that you just got. You have the biggest office at Adafruit right now.
Yeah.
So,
I have the photo.
Yeah.
And I have privacy curtains and everything. It's really crazy.
Yeah, we went to town on the credit card to B&H. So maybe tell everybody a little bit about what you built.
Okay. So I guess the first thing is the camera that I got is the Nikon D800. which is a really high-end DSLR, 36 megapixels. It's pretty much a medium format camera in a 35 millimeter form factor.
Gotcha.
And I got a couple of really good lenses.
Why do we need high res? I mean, like somebody would say, well, you're just going to post on the web. Why do you need such high res?
Yeah, I mean, I would say 36 megapixels, in fact, would be more than almost anybody needs unless they're doing really large prints. But the nice thing about that resolution is you can go crop to anywhere.
Yeah.
So let's say, I take a picture of some crazy kit and then I want to isolate one part of it to show. I can do that because I have all the resolution in the world to just go in there and grab it.
Okay.
Yeah, also, we're posting all of our stuff on Flickr, and we're making some prints, and we believe the future is huge videos, huge photos. Retina displays are around now. So our learning system, for example, will show the best possible photo based on your display.
Yeah.
So what lighting did you get?
I got a couple more. We had some Alien Bees monolights, and I got a few more of those, the B400 and a B800. They're pretty basic monolights. But the thing I like about the company that makes them, Paul Buff, is that they have a lot of modifiers, and they're not that expensive, and they're well made. The other thing is it's actually easy to make your own modifiers. Most lighting systems, to attach things to the light, there's this proprietary bayonet system where you have to slide it on and lock it, and all the pins have to be in the right place for that brand. Paul Buff is just these two clips, so if you cut a 3.5-inch hole with a hole saw, you can put anything on that light that you want.
That's cool.
Which is nice. But I also, mainly it's because I like the quality of the light that they produce. They're not that expensive. They're made in the USA, assembled in the United States. And they have a lot of accessories available for them. So you can get all kinds of soft boxes and grids for soft boxes and big reflectors, little reflectors, stuff like that.
Okay, we're going to answer a couple quick questions, and then we're going to go into new products. Someone has a DSLR and a macro lens, but the lighting and stuff to square up. What do you recommend on the cheap?
The lighting is tough. When it's kind of hard to answer that. Most people have problems with macro because the lens itself is casting a shadow on what you're trying to take a picture of.
It's so close.
Yeah, there's so many LED ring light projects out there. LEDs are not the greatest light source, but you can get away with them. If you just want to take some neat close-up shots where you don't need perfect color in addition.
I'm definitely to spend money on the lights and cheap out on the camera. That's how I got all the photos.
Lights are
I would
better
spend
than-
money on lights, and then the camera is $300, but the lights are a couple thousand because you can get really far if you have okay lights. With a crummy
Yeah,
camera.
that's true. It's always about the light. It doesn't matter what camera you use. I could use a Holga.
Yeah.
If I had good lights, I'd still probably get some pretty good shots if I had control over all the lighting.
And as far as cameras go, just briefly, then we'll hop into new products. So Nikon versus Canon. Why'd you pick the Nikon for the Adafruit Studio?
Well, I originally went with Nikon because it was what I knew. Well, for you guys, I picked it because it's what I knew. I originally went with Nikon because I already had inherited a Nikon film camera, and I had all of these lenses, and I didn't want to go out and buy $700-800 worth of glass for my DSLR, so I went with the Nikon. Nikon had just come out with the D200, which was the first really good Nikon DSLR that was affordable to me.
And then let me ask another question. How do you do backgrounds? Actually, maybe we should save that for when we get to the pictures and the new products.
Okay.
So you have a great one.
Sure.
Okay, so we'll answer more questions about photos, but let's we've got about 15 minutes of the show, so we gotta get to the code first. December is the code, 10% off everything in the Adafruit store until midnight, and it's now new product time. We're gonna race through these later. New products, new.
New.
All right, let's get through these really fast. I could start.
You made a sticker.
We've got Raspberry Pi stickers. These are official and approved from the Raspberry Pi Foundation. A portion of each sale goes to the Raspberry Pi Foundation. We got permission. Awesome. We're making stickers.
They're
$1.
really nice. They're
$1.
vinyl. They're vinyl color
beautiful.
stickers. They'll last forever.
Here's my laptop.
And they also, you can put them on stuff and remove it, and it won't leave the annoying sticky residue. So you can move it around.
Yeah. Next up, this is the Papercraft lunar landers that have LEDs lit up.
Sparkle Lab.
Yeah, these are
from Sparkle
They're
Labs.
super cute. They're a fun little project if you want to do a non-soldering electronics project. They're safe. They're non-toxic,
Yeah.
no soldering.
John, you took this photo. What did you have to do? This is a beautiful white background.
Actually, I can't take credit for that. That was the Sparkle Labs folks did that because that art on the left is too amazing for me to have ever done.
Oh, really?
Yeah.
They had good photos.
Oh, okay.
Describe
We were doing it and then we found those and we were like, wow.
So Ariel, who's there, is a fantastic designer, and he has a wonderful eye. I thought this one was your
These were a
photos.
lot of fun though. When we were Becky and I were having craft time
Oh, awesome.
and putting them together.
Very cool.
This is just a standard diffused white shot. For something like that, that would work really well.
Okay.
And
And
this is a
So is this.
breadboard-friendly MIDI jack. So we actually had a couple of these jacks left over from previous projects, and we're like, hey, we should put these in the store. Basically, your standard 5-pin DIN MIDI or DIN sync jack. And the nice thing about them is the pins are on a 0.1 inch spacing, and so you can actually just plug this straight into a breadboard or a perma-proto and go to town. None of the pins will collide with any of the others, so you can just wire them up. And we even linked to a great Arduino tutorial on how to make a MIDI controller out of an Arduino, because an Arduino makes a great MIDI controller. This project is a pretty simple product that we actually we finally got to putting in the store. It's a PS2 keyboard adapter, so you can plug a PS2 keyboard into it, and it has a little microcontroller and it will spit TTL serial output. So if you have something that, PS2 is a bit of a time-sensitive protocol. You actually have to sit and wait for the keyboard to send you interrupts. But the nice thing is, instead of that, you can have this, which buffers the data and then sends it out as like ASCII text. So that can be kind of convenient if you're just trying to get a keyboard attached to something.
Okay.
We also have this fabulous new perma-proto. This is a special perma-proto that's a perma-proto Pi. And basically, people were asking, like, well, I have like a cobbler and a breadboard, and then I have this project, but now I want to finish the project and finalize it. And they were like, it's actually kind of hard to connect the Raspberry Pi to a perma-proto because the pins are like, you'd have to get a cobbler and solder, and it's complicated. So what we did is we actually took a perma-proto, and then I'll show on the overhead because it's a little unusual what we did here. But we took the perma-proto, which is a standard sort of breadboard layout thing going on here. Oh, hold on, sorry. And then over here we stopped it, and then we put basically kind of a cobbler with a lot of breakouts. And so it comes with this connector, and you just have to solder this connector in, and then you can plug in your Raspberry Pi project into here, and then you can use wires to connect from these breakouts to the power rails or to the pins over here. So it kind of combines a Raspberry Pi cobbler breakout with a breadboard breakout. And we'll have these in different sizes, but the first size we got in stock is the full size. So that kind of explains what that's up. And check the photos, because there's a big photo showing all the pins and the very nice silk screen that we got.
Next up,
We've got two servos. I'll actually show the big servo on the overhead. These are.
John, did you take this photo?
I did, yes.
You did.
These
Okay.
are really cool motors too.
Yeah.
These are servos that are Metal Gear servos, not to be confused with Metal Gear Solid, which I played on the PlayStation, and that was an awesome game. This is different. These are servos, and inside I can show. Usually servos that are lower cost. They use usually a mix of plastic and metal or plastic gears. This, first off, it has a huge motor, really nice big DC motor, and a nice well-made control board here. And then here you can see that these gears, they're a little gray because they have oil on them. They're greased, but it's a full metal gear train, which makes this extremely high torque, very strong. This is really good for robotics. They're a little bit more expensive and they're a little heavier because of these solid brass gears. And there's very nice bushing here. There's a nice full metal bushing. Also, not to be confused with the Full Metal Jacket, which is a great movie by Kubrick. So we've got this both in the large size. I took this apart with screws. It's really nice. You can actually open it very easily and work on it. Or you can also get it in the micro size, which I have somewhere here.
Going to be upgraded to titanium gears.
That will be a $50 servo. So, but it is a little heavy. I agree that the brass makes it a little bit heavy. It comes with a full selection of horns as well.
Okay. All right. And moving right along, we've got this, and now this is where we're getting the John trigger. Look at this beautiful photo.
Yeah, that's a great photo. So this
look
is
at these.
basically, this is kind of interesting. It's a they are a little bit expensive, but these are like totally awesome, totally weatherproof sonar modules. And the cool thing about this is that you can put this on an outdoor project, and they're designed for only detecting large objects, and it does all the computation for you. They're in this nice potted compound.
Yeah, let me just say, we basically got these for Chris Courtright with a snow-blowing Raspberry Pi powered
It was a good idea.
Bot. So.
Yeah, can you just show it really fast?
Yeah,
I want to show it on video. Nope, that's me. Hi.
Sorry.
Close. Yeah, so it has this nice horn also to direct and make sure that it only points in the direction of where it's trying to measure. It's potted background, and it's got this thread, so you can put an O-ring and make this fully waterproof. Check the data sheet for the specific distribution, because it has a range and an angle, and then on the back there's like 6 different pins, so you can have like serial output, analog output, I2C output. There's a lot of different outputs. So this is a really nice, good range sonar module. So this is a nice collection to our Maxbotic sonars.
So this was the first product photo I took was for this product.
Yeah, this is nice.
And so tell us, how did you pull this off? Because it looks like it's in like a magic land that's computer generated. How did you do this?
Yeah, it looks like a 90s like generated.
Scoot up to the mic.
Okay, so basically for this shot, there's a table, so I'll kind of show you with my hands. So there's a table here. This is where the object is. There's a light underneath it with a grid to restrict its fall off, so that it makes that sort of radial pattern, like in the back.
Yeah.
That's under the table, pointing at the background, which is just a neutral gray. Then there's another light above, off to the left slightly. It's just a large softbox. And basically that's what I did. You kind of have to play around to get the light matching, so that you don't blow out the background, and at the same time you don't want the background to be too dark, because then that kind of defeats the purpose of this sort of glorious halo around the object.
It's very difficult to take photos. When I took photos, it's hard to take photos of things that are white or neutral colored. Because either you have a black background and then it looks really harsh, or it's a white background and then like you have nice shadows, but I would never be able to get really good shadows, so it would be just like totally blown out.
It's hard to give the things definition, yeah.
Yeah, it's like a totally neutral gray color, right? And it's smooth.
So
too.
here's my question: how much post did you have to do in like Photoshop and color correcting after you're done with the photo?
On this, I don't really think I had to do a lot. As long as you get the exposure correct, and really, the biggest rule of digital photography is check your histogram religiously, because that's got all the information you need on whether you got a good exposure or not.
So you want to see like a good
Yeah. You want to see it basically, you want to see maybe a peak in the middle and off to either side, but not where it's obvious that you have data that's clipping at the high end and being lost at the low end.
That's a good tip.
You want to kind of keep it
and you also don't
within
want
that range.
you also don't want it to be like dropped off too fast. You want it to be like a nice spread, right? Or like you want to have
there
it
are
like
some things that don't work well for that, where there's only like certain fixed tonalities. But something like this, where you have so much gradation, you would have in fact like a nice
grayscale,
smooth, It would look like a.
So there's already a ton of requests. I'll just summarize. Everybody would love a like Adafruit learning system tutorial on like how you shot like one photo like that.
Okay.
You know, in a tip. So John, you have some homework.
I like this because they have a little bit of soul, right? Because like my photos tend to be like product on a white background, but this is like it's 3-dimensional. Like you see it. You know.
Yeah, you can sort of sense what it would feel like in your hand, and
and the texture, you get a good sense. Okay.
So speaking of, here's another one in that same type of series. Like, look at this. This is
awesome.
This is
it's funny because it looks fake.
This is the clear Raspberry Pi cases we got, and we call these the.
It's not fake. I was there.
The Pi shells. And here they are, just without the Pi in them. And then I want to show. This is my favorite one. Looks like the muffler off a Tron cycle fell off or something. You know.
That's right.
And this is what it looks like off of it, of course. But
both look good. I mean, of course, it looks totally awesome. It's like the monolith here, so it looks like it's reflective. Is that a Photoshop effect? How'd you get that reflection?
It's actually sitting on a piece of black plexiglass. It's from the monochrome clock.
Way easier than Photoshop.
In fact, black.
Is that what they use? Is that official? Like people use acrylic? Because acrylic gets quite shiny.
It is in most studios, though. You don't really use it because you can't use it for very long. It gets scratches on it, and it really starts to show.
Yeah.
So the better option is to use something like privacy glass, like a sunroof type glass. Or sometimes the skyscraper glass, but not the mirrored kind, just the regular.
But you just were like, hey, I'm going to go to the laser cutter and grab some scrap.
And because I just wanted to sort of, when it's brand new, it looks really, really good. So it's nice and smooth.
And then
there.
like one fingerprint, it's like as you can see.
Yeah, you can clean it with a microfiber cloth, but eventually even that starts to show.
I have the
scratches.
Novus stuff, but like it's like why are you spending an hour polishing $5 for acrylic?
Yeah.
It's kind of a little crazy.
The other nice thing with the glass is it's a little heavier, so it sort of, whereas the plexi kind of moves around.
It does bend, yeah.
And it warps too.
So you did the same sort of thing where you have a light underneath shining at this neutral background, and that how gives it that sort of like sunrise effect.
Yep.
And it's sitting on top of black acrylic.
Yeah, there's actually there's 3 lights in this scene where you have the I'll show the folks at home. So it was sitting like this, and basically I had a light underneath the table shooting this way, and then I had another light up here, and then I had another strip softbox over here. As you can see, if you go back to the photo,
Well, where'd it go? There it goes. Yeah.
there's this like slight line on the right side, like a bright spot.
Yeah.
Yeah.
That gives it some different definition over there. So I put a little strip box.
I'll zoom in here a little bit so people can see.
You can kind of see it. It's in there.
I do see, like the HDMI connector, it seems a little brighter than it
'cause that
should be.
that was too dark
yeah,
before.
Yeah, you can see how normally there would have been a shadow that hides it, but then instead it just added a little bit of light to bring out that connector.
Yeah.
All right.
So
and
that's how
now,
I did both of these.
The star of the show, I think, tonight, besides John Engineer and Lady Ada, is this new product. This is the Adafruit NeoPixel 60 LED per meter strip.
Yeah, we have some right here. It's been sitting here.
These
Nice and
are
glowy.
amazing.
That's why
so
we're
let's
so glowy.
let me show you the chip on this.
Yeah, these are really interesting. So for a
Let's,
long time, like we've carried the 32 LED per meter, and it's basically like simple, low cost. And the thing that's nice about the 32 LED per meter stuff is it's SPI-ish, which means that any microcontroller can use it. Like pretty much people have ported my code to like the Netduino, the Basic Stamp, the Propeller, like
Probably even an
AVR.
8051 or something.
Everything, ARM, everything. Raspberry Pi, we got it working.
Yep.
And then we've had that for a while, and then people were asking for higher density LED strip. People wanted more LEDs per meter, and that for making like high density displays, or they want something that looks good. And they also wanted something that was thinner, and this stuff is thinner. So we found this really interesting LED strip, and the cool thing about this LED strip is if you look at this photo, I can't show it on the overhead because the overhead will not be able to display
Dominate the overhead.
Yeah, it's too bright. But if you look at the photo that we have of the chip, the LED itself, the way they get the high density is that there's no chip. That usually there's a chip and an LED and chip and LED, but the thing is, if you do that, there's like a maximum density of like about 40 LEDs per meter. You can't actually shove more stuff on a single-sided strip because you have to have these cut points. So what's interesting is that this LED strip has the LED chip inside of the LED. So the controller chip is in the LED, and so the LED, instead of being like red, green, blue, it's actually power, ground, input, output, and then there's one pin that's not used, and then one pin that's another power pin for the LEDs. And so there's some good things about this and some bad things. The good thing is you get this ultra high density. The bad thing is that you don't have 2 pins for input and output. Instead, you have only 1 pin for input and output, and it uses sort of a pulse coding system to set the colors, and it's full 8-bit per LED, so it's like 24-bit color, which is awesome. But the trade-off is you cannot use this with a microcontroller that does not, or computer that does not have precision timing output. It has to be 100 nanoseconds or better precision timing output. It has to be repeatable. So that means you can use it with an Arduino because it's real time. You turn off interrupts, and you've got, when you set the pin high, the pin goes high immediately. You can also use it with a propeller because you can use a core to do that.
Right.
You can also use it with any PIC, like ARM Cortex microcontrollers and stuff. However, you cannot use it with a Raspberry Pi or a Netduino or Basic Stamp because these are interpreted computer platforms. The Basic Stamp interprets the BASIC. It's too slow. The Netduino also does interpretive.net.
You're not close enough to the metal.
It's not real SPI. You can't. With SPI, it's different because
It has to be faster.
It has to be faster. But it can't interpret the instruction. It does like 1 kilohertz or a couple kilohertz output. You need much faster. You need like a megahertz output to pulse this out. And the Raspberry Pi has an operating system that interrupts the background. Now, if somebody wanted to, they could probably write a kernel module that would drive this. However, I'm pretty busy. I'm not going to do it. Somebody else might do it.
You could if you wanted to.
You could if you wanted to. The Raspberry Pi does have the ability to do that, but not in user space. It is a serious amount of work,
Right.
not for a noob or beginner.
Yeah.
But yes.
Not a lot of heat on these, but it's warm.
Yeah, another thing to watch out for is because of the high density, you need a really good power supply. Because with the other ones, you could use 2 amp power supply, you can get away with driving a couple meters. This, you need a 10 amp power supply to drive it. This stuff is super, super bright, super dense. Let's maybe check it out on the overhead real fast.
Yeah.
So I can show off.
Let's blow out this camera.
It's gonna be a little bright, but we can show it off. So what you can see is there's LEDs, and then you can see the connector dividers in between, and this lovely color output. And so I'm just doing a rainbow sweep here. But yeah, it's super bright. They are as bright as the other LED strip. We don't have an exact data sheet for the LEDs. I'm still working on it. I want to get this in the store, but it is hella bright.
John, how do you even begin to photograph or film these? Or you just can't. You can only be shown them. How do you do it?
Yeah, I mean, you kind of, you kind of have to decide what's most important to you and sort of throw everything else out because there's no way.
Church and family.
Yeah.
No, I don't know.
Baby bathwater.
Yeah, you kind of. There's no way that I could really show what this kind of looks like because I'm basically using a photograph of reflected light, and this thing is generating its own light.
Yeah.
So it's kind of hard. What we kind of went for was I wanted to make sure that all the colors were represented clearly. You sort of again with the white background actually makes it more difficult because you're shooting on white, and white is the brightest color.
Why not shoot on black, or you can try that?
You
later?
could shoot it on black is a little difficult too. Gray is probably a little bit easier. And I may actually redo this on gray.
Yeah. It's tough because our eyes, it's really bright,
Yeah.
but it's very hard to show how bright it is because if it's too bright, it blows it out, and if it's too dim, it looks washed out.
Right. The other problem is, I mean, just the difference between a pixel and the space between the pixel.
Yeah.
It's the dynamic range is so high that there's no digital camera that can actually capture that.
Yeah.
Film might be able to do it, but
Humans are cool. We can actually see.
Yeah, we have really, really wide dynamic
We have
range in our
logarithmic
vision
vision.
system.
So one quick question. Someone wants to know, would you be able to hook up 200 strips together? I guess if you had enough power.
You can. It's basically a power thing and a timing thing. I think with 500 pixels, you can do 30 frames a second. I think I calculated it out. You can do that. You can do the math.
Like a TV.
But you can drive. You can chain as many as you want. The problem is that the more you chain, of course, you have to write the whole strip at once. It does take longer. You have to inject 10 amps of power into every 4 meters of LED strip. It comes on a 4-meter strip thing. Or you can cut it up and inject power in multiple places. That's what usually people do when they make really big arrays of this LED strip, is they inject power. That's what you're going to be killed on. Also, you need a lot of RAM to buffer the display. You need 3 bytes per LED, and you have to buffer the entire strand in memory. So something like a Mega would be a really good choice for if you wanted to do a big display.
All right. George said we have a couple extra minutes, so we're going to open up some questions. If everyone could just stick to photography questions, since John's here.
Yeah.
We're just going to do questions for a few minutes. We got through all this. Whew, thank you, guys. That was fantastic.
I know. I want to show everything. We've all
All right.
Show all the things.
Yes. Show all the things. All right. It's question time. All right. How do you take a picture of a black object on a white background?
Well, you have to kind of make a choice. Do you want to bury the object, or do you want to blow out the background? You could really, really overlight. If you have control over the lights, you can overlight the subject while not making the background any brighter. But if it's something that you don't really have control over, maybe grab some reflectors and fill in the shadows on the subject so you can bring it up a little bit. That's really the only thing.
If you're photographing a black object, would you normally want to try a neutral or gray background, or?
Yeah, if you have control over the environment, you definitely want to do something like that. You don't want to set that kind of high contrast task for yourself.
Okay, 3 questions, and then we'll wrap it up. How do you take a photo of a white object? How do you photograph black cats? And then how do you photograph reflective objects?
What was the first one?
How do you take a photo of a white object?
Well, I mean, I don't really know how to answer that. It really depends on what the shape is. There are ways to get...
Well, the sonar is kind of white. It's a gray white, and so what you did is you put it on a gray background.
Yeah, part of the key to that, to get the definition to come out, is actually have a light source that's far away. because it will give you a nice smooth gradation on the
Okay.
object. Whereas if it's right up close, it's just blowing it out.
So yeah, light far away, lighter colored objects.
Yeah, light far away both reduces contrast a little bit, and it also gives you what's called collimation, which is it's a point source, so it has more of a, I forget the word. The way the light falls on it, it creates more of a gentle shadow.
Qualia. How do you photograph reflective objects?
Like a silver object, probably the easiest thing to do is you get some white cards to reflect back on the object so that you can see how they just, like if it was a silver sphere or something.
Yeah.
Right? You put maybe a white card over here, and then the reflection of the white card would actually give you the definition of the object because it would be reflecting like a rectangle. The other thing is maybe shoot it on a light background and see how the I forget the word, but you know what I mean.
The reflectance,
Like a horizon.
Yeah.
Will reflect around it. Maybe a varied surface.
And then we'll just do one more. What is the best? Where'd it go?
How to shoot a black cat? How'd you shoot monster?
Well, would you use a flash with photography or a spotlight? Should you use a flash with photography or a spotlight? That's the question. Because it depends.
Yeah, it really does depend.
Yeah.
A spotlight is going to be a lot more work.
Yeah.
Flash you can keep on your camera, but I tend to think that a light off camera tends to look better than a light on camera most of the time, unless you're bouncing that light off the ceiling or something.
Okay. All right. Let's do a trivia question. Thank you. So.
Okay.
Great round of questions, and everyone probably wants you to do a blog post once in a while or something.
Yeah.
With the gear that you bought, or just like maybe when you come up with a tip or a photo note, like when we post it on the blog of a new product, you could say, "Oh, for this I did that." Maybe you can just go in and add it. Yeah. People are really interested in that. Okay, we're gonna do the trivia question now. It's trivia question time.
Okay. Oh wait, we forgot the.
What?
We'll do
Oh,
that.
that's all right. Next week. Okay, trivia question, Lady Ada. What's the rules for the trivia?
Okay, the rules of the trivia question is if you've entered this contest and won a fabulous prize, you cannot enter the contest again because we want everyone to win a fabulous prize. The first person to type in the correct answer with spelling wins the prize. The prize today is a meter of this awesome NeoPixel, super awesome high density LED digital strip
And then you
stuff.
can see for yourself how bright it is.
And you can see how for yourself how damn bright it is and how hard it is to photograph.
One quick question, because someone did ask. They want to take pictures of. They have black cats. Actually, that was a real question. So how would you?
I was a kid. There's somebody else.
Yeah.
Yeah. Oh, how would I take
Moscow looks great in the sunlight.
Yeah, something like
Yeah, because his hair picks up and reflects the light a little bit.
Yeah.
Obviously, I wouldn't try to take a picture of him like on something black because then he would just be blending in. But like,
So sun.
put him on a medium background, maybe like a gray or even like this floor.
Yeah.
Which isn't quite like bright white.
Yeah.
Something that gives him definition.
Okay. You win the
maybe
trivia
light him
question.
from the side so that.
That's a trivia question.
Yeah.
The question is how to.
Here is a trivia question. The prize is the NeoPixel. And the question this week is, first person to type this in, if Lady Ada Lovelace was alive, how old would she be right now in years? How old would Lady Ada Lovelace be right now in
And remember,
years?
only enter if you've never won before. If you have,
Not
if you've
42.
won before,
Not
sit on your
87.
hands.
Not 127, not 170. Not 100. Hit the Wikipedia page, folks. Pi is the wrong number. Good guess though. Everything is 42, 128, 285, nope. 167, nope. Unknown domain. You won, 197 years old. That's how advanced she was. She was already thinking about programming computers 197 years ago. It's incredible. It's incredible. So what I wonder right now is there a modern day Lady Ada Lovelace? I don't know. And what is she thinking about that people are going to look back and say, how did she come up with that 197 years ago?
How to photograph LEDs.
How to photograph black
cats
cats
at the same time.
Yeah.
How do you photograph black cats and LEDs?
Do email us at support@adafruit.com and we'll send you that pixel. Let's do some quick rounds. Thank you, Paint Your Dragon. Thank you, George Graves. Thank you, Colin.
Hey, George.
Thank you, Kevin. I think he was maybe out there.
K-Town.
I think he was. I don't know if he was in and out of the chat. Phil B is there. Paint Your Dragon. Thank you, everyone. Just one last thing again. The entire Adafruit team wanted to say thank you, everyone, for being fantastic community members, people in the chat, people on our social networks, people in the forums, customers, all this stuff. Thank you so much. This is the first time we had a group photo. We're very happy.
It's a good crew.
Yeah, good crew. We have a lot of people around the world. We can't, of course, put them all in a photo, but we sent this photo to everybody that was remote, and we also had a little video where we said hi. So with that being said, that's it for Ask an Engineer this week. John, thank you for coming in, and most of all, thank you for joining us on this adventure. I've known John for a long time, and I'm so happy we have a company where we can have a director of imaging. We got Colin, our creative engineer. We got Phil, a creative engineer in California. We got
Coops.
We got the Coops in Minnesota. We've got Kevin in Paris. We got George in Washington. We got everybody all over the place. We got Bill
MOSFET
and Rick.
on the couch.
We got MOSFET. We've got all of our friends and partners around the world. It's really good.
We have a lot of people.
And we're exhausted.
We have a lot of friends.
We're going to go to bed.
That's right.
So thank you, everyone. And we'll see you next week.
We have to test the
Bye, everybody.
The pixels.
Bye, everybody. Some big news coming this week. You'll see on the blog. Yes, I think he's on the couch right there. If you can go grab him.
Okay, I'll go grab him.
We have LEDs so we can light him.
Yeah.
That's right. And then I can try to take a picture.
Yeah.
He's totally sleeping. He's like, wait, why are you waking me up?
Yeah.
Oh, no, not a tired cat. Oh, he was so tired, he was sleeping.
Here is your moment of cat.
That's right.
Yeah, you can see cat more. Look at that.
I was hoping he would meow into the mic. I think he's kind of freaked out. Hello, is this on?
Okay, here is your moment of Zener.
Bye-bye. He really likes you. He's like,
I
oh,
guess.
my God.